Goldstein discovered protons during the production of anode rays. He observed that anode rays or positive rays were produced simultaneously with the production of cathode rays. Production of anode rays or canal rays. Discovery of protons by Goldstein. The apparatus used is as shown in the diagram. It consists of a discharge tube which is connected to a vacuum pump to reduce the pressure inside the tube. There is a perforated cathode, that is a cathode with a small orifices or small pores like this. At the other end of the tube, an anode is used. This is anode. If a gas like hydrogen is filled in the discharge tube and subjected to high voltage at low pressure, cathode rays were produced, as we have studied. See, cathode rays are produced from cathode and traveling towards anode. These rays are called cathode rays. See, we are not going to study cathode rays, but we are going to study anode rays. How are they produced? How are anode rays produced? I'm going to explain. See, you know that cathode rays contain negatively charged electrons. The electrons of the cathode ray may knock out the electron of hydrogen atom. You know, hydrogen atom contain one electron and one proton. It does not contain neutron in the nucleus. So, electron of the cathode ray may knock out the electron of hydrogen atom, producing unipositively charged express ions. So it's clear that express ion contain only one proton. Why? Because electron have been knocked out. So the remaining part is only proton. It does not contain neutron. So what happens to these express ions or positively charged ions? These ions are produced in the space between perforated cathode and anode. As they carry positive charge, they are repelled by the positively charged anode. So they move in a direction opposite to that of cathode rays, and they will come out of the perforations of the perforated cathode like this. They gather together to form anode rays. So it's clear that anode rays are produced. Anode rays are produced only after the production of cathode rays. That's very clear. See, if hydrogen gas is used in the discharge tube, the anode rays contain H plus ions. Let us see the properties of anode rays. 1. Anode rays are deflected towards negatively charged plate. So they contain positively charged particles. Anode rays are deflected towards negatively charged plate, so they contain positively charged particles. Second point, they are affected by the magnetic field. Anode rays are affected by magnetic field, and the affection shows that, the affection of the magnetic field shows that anode rays contain positively charged particles, Third point, E by M value of the particles present in anode rays, that is positive ions present in anode rays, change with the change in nature of the gas used. That is, E by M value of the positive particles present in the anode ray depends on the nature of the gas used. So, E by M value changes with the nature of the gas. It was found that the positive charge of the particles present in anode rays were always integral multiple of unit positive charge, that is fundamental charge. For example, if hydrogen gas is used, S plus ions are produced with one positive charge. If helium gas is used in the discharge tube, He2 plus ions are produced with a 2 unit positive charge. If lithium gas is used, Li3 plus ions with 3 unit positive charge are produced. If hydrogen gas is filled in the discharge tube, only S plus ions are produced. They are called protons. See, the charge of the proton is 1.602 into 10 raised to minus 19 coulombs. That is plus. The charge of the proton is equal to that of electron. Equal in magnitude but opposite in sign. For electron it is negative and for proton it is positive. This is called 1 unit positive charge, and the charge of the electron is 1 unit negative. Okay. Mass of the proton is 1.6726 into 10 raised to minus 27 kilograms. This mass is 1837 times the mass of electrons. That is, mass of the electron is 9.1 into 10 raised to minus 31 kilogram. That into 1837 will be the mass of the proton. That is why we say the mass of the proton is 1837 times the mass of electron. On the other hand, we can say that mass of the electron is 1 by 1837 times the mass of proton. That's all. Now let us see what is the E by M value of the proton. E by M is equal to, E by M of the proton is equal to, see, charge of the proton is 1.602 into 10 raised to minus 19 coulombs. Mass of the proton is 1.6726 into 10 raised to minus 27 kilograms. That is 0.96 into 10 raised to 8 coulomb per kilograms. That is 1.602 divided by 1.6726 is equal to 0.96. This comes in the numerator. So we get 10 raised to 8. Now converting it into scientific notation, we get, taking 10 outside and multiplying with this, we get 9.6 into 10 raised to 7 coulomb per kilograms. This is the E by M value of the proton. See, this is the E by M value of the proton. This is the charge of the proton and this is the mass of the proton. That's it. The most important usage of the anode ray is that it is widely used. Production of anode ray is widely used in analytical chemistry, that is in mass spectroscopy. If we use a mixture of all the three isotopes of hydrogen in the gas inside the discharge tube, then anode rays contain unipositively charged ions of protium, deuterium and tritium. That is the unipositively charged ions of the three isotopes of hydrogen. If this anode ray, this is the anode ray produced by the isotopes of hydrogen, are passed near a magnetic field, they will be attracted by the magnetic field according to their mass. So anode rays will split into three. Lighter isotopes are strongly attracted by the magnetic field, so we get three splits up and we get three lines in the mass spectrum. By counting the number of lines and studying their intensities, it is possible to identify the number and estimate the relative abundance of isotopes of hydrogen. Similarly, we can analyze other elements using their gaseous samples in the discharge tube. Discovery of neutrons. James Chadwick discovered neutrons. When beryllium or boron is bombarded with fast moving alpha particles, neutrons were produced. See Be49. When Be49 is bombarded with alpha particles, neutrons were produced. Neutrons were produced. See, let us check the atomic numbers and mass numbers. 4 plus 2, 6, minus 0 is equal to 6. That is the atomic number of the missing element. Then 9 plus 4 is equal to 13, minus 1 is equal to 12. That is the mass number of the missing atom. See, atomic number 6 is carbon. So, carbon 612. This was the production of neutron. Neutrons are neutral particles with a charge is equal to 0. Mass of the neutron is 1.675 into 10 raised to minus 27 kg. That is, mass of the neutron is nearly equal to that of proton. For proton it was 3 here, but for neutron it is 5 here. That is what is the difference. Therefore, mass of the neutron is 1.675 into 10 raised to minus 27 kilograms. Sometimes we may be asked to answer for a question. Arrange the following in the order of their E by M values. Electron, proton, alpha particle and neutron. You know that E by M of electron can be expressed as charge by mass of the electron. Now, E by M of proton can be expressed as charge by mass of the proton, that is mass of the electron into 1837. Why? Because mass of the proton is 1837 times the mass of the electron. So, ME into 1837, that is E by ME into 1837. And what is alpha particle? Alpha particle is a double positively charged helium nucleus, He24, with a 2 unit positive charge. So, charge is 2 times that of this, that is 2 into E by Mass is mass of the electron into 1837. That is mass of the proton. And mass of the alpha particle is 4 times the mass of proton. That is why we put 4 here. See, what about neutron? It is 0. So from this it is clear that E by m value is larger for electron than proton, which is larger than alpha particle, which is larger than neutrons. So the order is electron is greater than, proton is greater than, alpha is greater than neutron. This is the order of E by m values. JJ.TThomson suggested a non-nuclear model of atom. JJ.TThomson's atom model. According to him, atom consists of a positively charged sphere of radius 10 raised to minus 10 meter. See, this is a positive sphere. Electrons are embedded in this positive sphere. Electrons are enclosed in this positive sphere like that of seeds in watermelon, plums in pudding, raisins in pudding, or mustard seeds in upma. See, so this model is otherwise called watermelon model or plums pudding model or raisin pudding model or mustard seed upma model, etc. See, electrons are embedded in the positive sphere. These are electrons. As a result of this, atom is electrically neutral. So, JJ.TThomson's atom model could explain electrical neutrality of the atom. Demerits. See, it is a non-nuclear model of atom. As I have already told you, it contained no nucleus. So, it could not explain the nuclear property like radioactivity. So it fails to explain nuclear property, namely radioactivity. It fails to explain chemical bonding. It also fails to explain the origin of atomic spectrum. That's all. Now we are going to learn Rutherford's alpha ray scattering experiment that led to the discovery of nucleus of the atom. A narrow beam of alpha ray is produced. It is then allowed to fall on a thin gold foil. See, gold is highly malleable, so it can be made into a thin sheet, even about 100 atom to 1000 atom thickness. That is, gold foil is highly malleable and it can be converted into a very thin foil. If alpha ray is allowed to fall on this thin gold foil, this is a thin gold foil, which is placed in the middle of a circular photographic plate like this. It's a circular photographic plate. It is placed around this thin gold foil. This is thin gold foil. This is circular photographic plate. This is alpha ray. It was observed that about 99.9% of the rays, almost all rays, about 99.9% of the rays are passing through the foil without any deviation. Some rays are passing through the foil with some deviation, and only a very small number of rays, about 1 in 20,000. Only a very small number of alpha particles, that is 1 in 20,000, get reflected back. Some of them even take 180-degree deviation. So from this experiment, Rutherford suggested that gold foil may contain atoms like this. I'm going to give you a close-up of the arrangement of atoms in the gold foil. We view only 2 atoms. It may contain a positively charged center like this. A large number of alpha rays are passing through the foil without any deviation because there is a large empty space in the atom. Some rays are passing through the foil with some deviation. It is because alpha particles have a positive charge. So if they take deviation, sometimes there may be a positively charged center and only a very small number of rays get totally reflected back, bounced back. From this it is clear that there must be a positively charged center in the atom, which is very small or minute. That is why only a very small number of rays get totally reflected back. So from this experiment, Rutherford concluded that atom consists of a tiny positively charged center where the entire mass and positive charge of the atom is concentrated. And there is a large space around the nucleus of the atom, which is called the extranuclear part. See, this is the advantage of this model. This model divides the atom into nucleus and an extranuclear part. A central nucleus and a large space around the nucleus called extranuclear part. Rutherford's atom model. Based on alpha ray scattering experiment, Sir Ernest Rutherford suggested a nuclear model of atom. Important postulates of his model or features of the model are the following. 1. Atom consists of a tiny positively charged center, positive center, called nucleus, and there is a large space around the nucleus called extranuclear part. Extranuclear part. Second point, the radius of the nucleus is about 10 raised to minus 15 meter, and the radius of the atom is about 10 raised to minus 10 meter. That is, the size of the atom is about 10 raised to 5 times larger than the size of the nucleus. In simple way, we can say that nucleus of the atom is just like a cricket ball placed at the center of a ground or playground of 5 kilometer radius. Third point, mass of the atom is mainly due to the nucleus, and volume of the atom is mainly due to the extranuclear part. Fourth point, electrons are present in the extranuclear part and they are revolving around the nucleus like that of planets around the sun. Electrons revolve around the nucleus of the atom like planets around the sun. Planets around sun. That is, if nucleus is like this, electrons are revolving around the nucleus like that of planets around the sun, like this. Fifth point, the total number of positive charges in the nucleus is equal to the total number of negative charges in the extranuclear part. Negative charges in the extranuclear part. So, the atom is electrically neutral. Fifth point. Sixth point. The centrifugal force of the electron is exactly balanced by the Coulombic force of attraction of the nucleus. That is nuclear force of attraction. So, atom is stable. The centrifugal force of the electron is balanced by Coulombic attraction of the nucleus. So, the atom is stable. These are the important postulates of Rutherford's atom model. Demerits of Rutherford's atom model. Demerits of Rutherford's atom model. According to Maxwell's electromagnetic radiation theory, when a negatively charged electron revolves around the positively charged nucleus, the electron may lose energy in the form of electromagnetic radiation. See, when a negatively charged electron revolves around the positively charged nucleus, this electron may lose energy in the form of electromagnetic radiation. See, this energy, losing energy or liberated energy, is at the cost of the kinetic energy of the electron. Therefore, kinetic energy of the electron gets reduced and it will be attracted more strongly by the nucleus. So, it comes closer and closer to the nucleus and take a spiral path, finally fall into the nucleus. Actually, if this happens, an atom may collapse. But this is not actually happening. Why? Because atom is stable. Therefore, Rutherford's atom model fails to explain the stability of the atom. That is the very important demerit of Rutherford's atom model. Study shows that if this happens, or according to Rutherford's model, atom may collapse within 1 by 10 raised to 8 seconds or 10 raised to minus 8 seconds. Therefore, Rutherford's model fails to account for the stability of the atom. Fails to explain stability. This is the first demerit of Rutherford's atom model. Second, it fails to explain chemical bonding in a satisfactory way. Fails to explain chemical bonding. Third point, it also fails to explain the origin of atomic spectrum. These are the important demerits of Rutherford's atom model.